So the reason why I want us to know them, hello, Mandisa. Okay. The reason why I want us to know these particular formulas is because everything that they're going to ask you in analytical geometry comes from a formula. So if you know the formulas, you're guaranteed to get 90% of the marks. I would gather 99% of the marks. The rest of it is just a little bit of logical deduction. Okay, so whatever it is that you need to do in order to get all of those right stem from knowing the formulas already. All right, so let's start with a very quick recap. Okay, we have the distance formula. I know the distance formula is the square root of x2 minus x1 all squared minus y2 minus y1 all squared. And we know that this particular formula is derived from Pythag, and it will give us the distance between any two points on the Cartesian plane. All right, from here we've got the midpoint formula. I want to remind you guys that the midpoint formula doesn't give you an answer. The distance formula will just give you an answer. The distance formula will say the 2 points are this many units away. The midpoint is going to give us another coordinate. So it will give us another x value and another y value. All right, so because it's a point on the actual Cartesian plane, it will give us another point. All right, and that's going to be x1 plus x2 all over 2, semicolon, because that's how we write the coordinate, and then y1 plus y2 all divided by 2. And I hear I hear someone's hands up. Yes, Mandisa?
Ma'am, for
yes.
the distance formula, isn't it a plus in between the two?
It is a plus in between the two. I'm the one who lied. Thank you so much, my darling. Thank you. Sure. Good catch. Thank you. Yes, because it's Pythag. Yes, we need a plus in between. Okay. Thank you very much, Mandisa. See, this is what I'm saying, guys. Mandisa could actually teach this class. I can take the day off. Mandisa can just do the things. You know what I mean? And then remember, you know, I just take my 100% commission off the top. While Mandisa will do the teaching, I'll just take the money. You know what I mean? You know what I mean? It's a win-win-win. Thank you, Mandisa. Thank you, my darling. Good catch. All right. Then we've got the gradient formula. The gradient formula comes from the formula of a straight line, because basically when we talk about analytical geometry, we're talking about straight lines. So y2 minus y1 over x2 minus x1. So I'm just going to add in a couple of other things. We need to know that if I have two lines, let's say this is line A, B, and I have another line C, D. If AB is parallel to CD, then the gradient of AB must be equal to the gradient of CD because they have the same steepness. So their gradient, their slope will be exactly the same. All right. Then I also know that if line AB is crossed by line CD such that they create a 90-degree angle, that means they're perpendicular to each other. So if AB is perpendicular to CD, then the gradient of AB times the gradient of CD must equal -1. Okay, and I'm going to expand on this just a little bit, especially this part here, because they're not going to give you a mark for putting this into a formula, and I'll explain to you why. Now, the idea of a -1 is actually a reciprocal of the other. So if I tell you guys that I want both of these two things together to give me -1, and I give you that one of them, the gradient of AB is -2. Okay, in order for me to find the gradient of the other, I'm going to then, hi ma'am, can I please excuse myself to pray? Absolutely. Thank you for letting us know, Didimalo. Good luck. The best of luck to you for the next paper. Okay. All right. Let me get back to my train of thought. Okay. Cheers, Didimalo. Okay. Yeah. All right. So if I've got -2, right, all I'm going to do is I'm going to put it over 1. To find the gradient of CD, all I'm going to do is I'm going to rewrite this in the opposite direction, 1 over 2, and I'm going to make it positive. That's all I need. All right. So If I find out that the gradient of the one number is 4/3, if the gradient of AB is 4/3, then the gradient of CD, if they're perpendicular, will just be 3/4 with a negative. Okay, right, thumbs up. Is everybody understanding what MAMS means here, or must I elaborate a little bit more? Okay, I can explain a little bit more. Yes, sorry, I'm hearing a voice. Yes, sir.
Ma'am, can I please ask over
Yes.
there on the gradient formula, is it okay to put x2 minus x1 first?
At the top?
Yeah.
No. Always y at the top. Okay, so a gradient formula is always the rise over the run. Okay, so gradient formula, rise over run. We first look at the rise, and rise speaks of y values because the y is the vertical, over the run, which is the x values that go in this direction. So never x on top, always y on the top and x on the bottom. Okay.
Okay, ma'am.
All right. Okay. Make sure. All right. Good question. All right. So in this case, I know that they're perpendicular. I know that 4 times 3 will give me 12. And 3 times 4 will also give me 12. And this will be a negative because it will be a negative times a positive. And my answer will be -1. So let me ask you guys in the chat then. If I find out that the gradient of AB is -2/3, what is the gradient of CD then going to be? If they are perpendicular. Everyone in agreement? Yes. Okay, if the one is -2/3, the other will need to be +3/2. And so because we have this relationship between the two perpendicular lines, they're not going to give you an extra mark for something that you can just flip and change the sign of. All right, but it is important that we know this. Okay, so all we need to know is if it's negative, you make the perpendicular to it positive and you flip it over. If it's positive, you make it negative and you flip it over. That's all we need to know. All right, thumbs up. Everybody okay with that concept? Yes? Yes, we are, Gift. Okay, Justin is still a little bit, let's see how it goes. All right, okay, excellent. I'm not quite done. Last thing we need to remember is the straight line formula. So we need to know that the formula for the straight line, y is equal to mx plus c. You can either use this one, which we're used to. Yes, Katlego, I see your hand. What's up?
So, ma'am, if
Yes.
we are given, okay, the AB is perpendicular to CD, but
Yes.
then, no, if we see, we can see what it's perpendicular, but have to prove. So,
Yes.
if it's not equals to -1, how do we
Mhm.
conclude?
Then the conclusion is that they're not perpendicular. In order for them to be perpendicular, the gradients must, the product of the two gradients must give you -1. Okay, and if it doesn't, check your calculations. If they say prove and your answer doesn't come out -1, then you must check your calculations. Okay, it must always come out that way. All right.
All right, thank you.
All right, and we'll do a question just like that in a bit. All right, okay, so this is the standard one. We know this one. This is what we learn when in grade 9 when we learn about the equation of a straight line. The one that we also learn in analytical geometry looks like this. It says y minus y1 equals the gradient multiplied by x minus x1. And I personally like this one a little bit better than this one. I use the second one a lot more because all I need to do is if I have my gradient, all I need to do is substitute, distribute, and then add two things together. Okay, so in this particular one, again, you would just do the same thing, but this one, I don't know. My brain just works a little bit better with this one. Okay, but we're going to see both of these working as we go, and I'll show you exactly how it is that they work as we go. You guys can use y is equal to mx plus c because I know you're used to it, but if you've also seen y minus y1 equals mx minus x1, we'll use that one as well. All right, thumbs up. Are we ready for a question? Can I give you guys a question on analytical geometry? Remember, guys, these things that I've just put on the screen are the basic knowledge we need to have going into a question. All right, you need to know this because they're not actually going to give you, they do give you the formula, they don't tell you which one works where. You need to figure that out for yourself. All right, let's start by reading the information. We know step number 1, read. Always read. Okay, so it says here, in the Cartesian plane below, points A, which is 5, 5, make sure there's an A, there we go, 5, 5, B, -7, 1, and C, 1, -7 are the vertices of a triangle. All right, then we're told that point S is the midpoint, so we already know that if they ask us to calculate for the midpoint, then we know we already have a midpoint formula that we can use in that case. Then it also tells us that the line AS is perpendicular. So you see, when we read this information they give us on the top, we already kind of know what it is that we can expect. All right, if we're looking for the midpoint, we know we're going to have to use the midpoint formula. When they tell us that AS is perpendicular to BC, we already know, before we start, we already know that the gradient of AS times the gradient of BC must equal -1. That's something we already know before we get started. Yes, Mandisa?
Ma'am, I just wanted to
Yes.
know, can I take over the class from 3.1 to 3.3?
You know what? Actually, we're just going to give them some time, and then I'm going to let Teacher Mandisa do her job. Guys, who am I to stand in the way of greatness? I'm absolutely here for it, my darling. We're just going to give everybody some time to do the questions, and then you're going to walk them through it. How does that sound? Yes?
Yes,
Are we
sir.
down? Ah, beautiful. Okay. I'm going to give everybody, let's see, 3, 5, 6 minutes. All right. 6 minutes to do 3.1, 3.2, and 3.3. And Teacher Mandisa is going to walk us through the answers. You've got 6 minutes, everybody, starting now. Okay. Do your due diligence. There we go. Oh, I forgot to point here. Point S is the midpoint. All right. Okay. 6 minutes, everyone. I'm just going to grab a cup of water and I shall be right back. I was just about to say we've got a little less than a minute to go. So let me know how you're doing, guys. I see quite a few emojis coming up on the screen, so that's helpful. But we've got just about 20 seconds left. So let's finish up really quickly. I was. All right, that's time. Okay. I'm going to be very silent for a little bit. Teacher Mandisa, would you like to unmute and take it away?
Yes, ma'am.
Oh, beautiful. Let's go.
Okay, so first things first, you have to first label your coordinates using the x1 and y1, whatnot. So you choose any coordinates. In this case, I chose B to be x1 and y1, and C to be x2 and y2.
Okay, good.
Okay, the question for 3.1 is determine the coordinates of point S, which is the midpoint of B and C. The formula for midpoint is x1 plus x2 divided by 2. For that's for the x coordinate, or x, I don't know what you call it. And then for y is y1 plus y2 over 2.
Beautiful. Okay.
And then you substitute your coordinates of B and C in that formula. And that would be -7 plus 1 divided by 2.
Good.
And for y is 1 plus -7 over 2.
Beautiful. Yes, ma'am. Keep going.
And the answers are -3 and -3. That's what I got.
-3. Like beautiful mathematics done so wonderfully. Of a beautiful 1 to 3 marks for teacher Mandisa. Just I don't know. I don't know the Italian word, but if I did know the Italian word, I would use it right now because you did that so beautifully, so excellently. Okay, all right. Shall we keep going? Yes?
Yes, we should.
Let's go to 3.2. All right. Okay.
Okay, the question is determine the gradient of the line AC. The first thing you do again is you label your coordinates. Since we already labeled C, we go to A and we'll make it x1 and y1.
Beautiful.
And C will remain x2 and y2.
Beautiful. Okay.
And then the formula to find the gradient is m equals y2 minus y1 over x2 minus x1.
Beautiful. All right, my darling, just don't stop. Just keep talking. I'm following exactly where you are, so just keep going. I'm writing down
Then
everything
you
you're saying.
substitute your coordinates, which would be -7 minus 5, and then over 1 minus 5. That would give you 3.
3 on the dot. Excellent. So
Ma'am, I
the grade-
also
yes.
I also calculated for the equation of the line. I don't know why. but I
Okay.
also did, so.
Well, it's unfortunate. It's only a 2-mark question, so they're going to stop marking once they've gotten exactly what they need from you. Okay. So don't do any work that's unnecessary, especially as a mathematician. We don't want any of that. Okay. 1 mark for the substitution, 1 mark for the final answer. Well done. All right. Let's talk about 3.3.
3.3. The question is determine the distance of BC.
Beautiful. Okay.
Now you will label your coordinates again.
Mm-hmm.
C will remain as x2 and y2, but B will then be x1 and y1 again.
Right.
And then the formula for distance is d equals that root thingy.
Square root, yes.
Open brackets x2 minus x1 close brackets squared plus open bracket y2 minus y1 close bracket squared.
Beautiful. Okay. All right. I just want to address a couple of questions in the chat really quickly before you continue, Teacher Mandisa. It says here, does it matter which one is X1? No, it doesn't. Manisa, Narisha is spot on. As long as your X1 and your Y1 are together. So you can't decide to do this. You can't decide that this is X1 and Y2. No. If this is X1, the Y coordinate must also be Y1. All right, so it doesn't matter in which order you do it, both of them will come out the same. Okay, as long as you sub right. And you know what? Actually, Teacher Mandisa, your teaching assistants in the chat are doing the job for me. So actually, I don't have to answer these questions because your teaching assistant, Narisha and Justin and Abu, spot on in the chat. They're doing the right thing. So keep it up, guys. Okay. All right. Oh, okay. That's okay, Javiso. Excellent. All right. Take it away, Teacher Mandisa. Finish up for us.
Okay, and then you substitute your coordinates in the formula, which would be the square root, open brackets, 1 minus -7, which just gives you 1 plus 7.
Good. It's going to become a positive there. Good. And then?
Yes. Then you add your squared at the top of the brackets. Then plus, open brackets, -7 minus 1, close bracket, squared.
Beautiful. Keep going.
Then
Right.
your answers are, I don't know if my answers are correct. I think they're correct.
Okay.
It's either 8 square root to the square root, square root
8
of 2.
squared. 8 squared.
Okay, 8 squared or 11,31.
Okay, so as I look at it over here, I'm thinking I should get the square root of 128. Is that correct? That should be my final answer, square root 128. And I'm assuming if I put that into a calculator, I should get something along the lines of 11 point something. Okay, because I know that the square root of 121 is 11. So my answer should be
31.
11,31. Beautiful. Okay. Guys, Teacher Mandisa, when they pay me this month, I think I might send maybe something from McDonald's your way. You know what I mean? Because I see what you do there. I see what you do there. Well done, my darling. That was so beautifully done. I want to use this opportunity to explain how to do 3.4, but I can't fault you anyway. Do you know how to do question 4? Yes?
Not really. I have an idea, but I'm not sure if it's correct.
Okay.
So maybe you can take it away.
All right. Okay, I will take over. Thank you so much for handing the reins over. I appreciate you. Amazing work. All right. Ma'am, will they ever ask you must leave the answer in third form? Yes, they will, Trulani. And when they do, you leave it under third form. So the word third means leave your answer underneath the square root. So don't click SD. You just leave the answer under the square root. Okay. So make sure you're following instructions exactly, but beautiful. All right. So let's look at 3.4 really quickly. 3.4 says here, determine the area of triangle ABC. So before we even continue, give me the formula for the area of a triangle, someone. What is the area of a triangle?
Area
Anybody
is given to you by half times base times
the
height.
base. Good. Times the height, right? Remember, not just any height, it needs to be the perpendicular height of our triangle, right? So if I say to you guys, I've got a triangle like that, and I tell you that this side over here is 8 centimeters tall, and the perpendicular height is 6 centimeters tall, you'd all be able to calculate for the area of this triangle. Yes, Narisha? I see your hand. What's up, my darling?
Ma'am, so for the formula, we already have the do we have the distance for the base already?
Absolutely good. I'm loving that you're noticing that it's the distance. And spot on. Please, assistant teacher Narisha, take it away. Good. Okay.
So, ma'am, now that we have BC's distance, we can calculate AS's distance because we have S's coordinates, and then we can find the area.
Just guys, I think my job here is done. I think I'm just gonna go take a bit of a rest because I don't have to do much else. And I was gonna explain all of that, but Marisha just kind of did it for us. She's told us we already have our base. All we need is the perpendicular height, which we can calculate because we have the coordinates of S. Thanks to teacher Mandisa, we know that the coordinates of S are -3, -3. And when we calculate for the area of anything, we just need the length. So we're using the distances. And I mean, okay, I don't have to do the job anymore. Does everybody understand what to do now? Yes, is everybody okay with what to do here? Yes, we've got the distance of BC, which is the base of our triangle. We need to find the height, the perpendicular height. We can use the distance formula to find the perpendicular height, and then we just use the area formula to find the area of the triangle. Yes, thumbs up. Everyone okay there? Are we all good? Can I give everybody like 3 minutes-ish to get through it? Teacher Narisa and teacher Mandisa, you guys are just cream of the crop, guys. I don't know what to tell you. I mean, okay, I'll give you guys some time to go through it. We don't need that long. Okay, I'm happy to write it down. Okay, so we know that the area of our triangle is half the base times the perpendicular height. Now we know that that is perpendicular there. They've given us that tiny little square that tells us that it's perpendicular. So we know that we have the base. We've calculated the distance of BC. We just need the length of the perpendicular height. And if we want the length, we just need to use the distance formula to calculate the distance of AS. Once we have the distance of AS, we're going to take BC, which is our base, multiply by AS and take half of that, like we would in the formula for the area of a triangle. Kanyo, does that make sense? Are we okay with that? Yes, all good. Amazing. All right. People are already done. So I don't know. I don't know if I should give any more time because most people are done. But Kanyo, I'm going to give you 2 minutes anyway, my darling. I'm going to slowly walk through it myself. Okay. See where it takes me. And then we will chat about the answer in just a little bit. All right. So I'm going to start by calculating the distance of AS. Okay. Slowly going through it. Okay, since A has already been labeled x1, y1, I'm going to label S x2, y2. Let me just write the coordinates a little bit better. Okay. Y2, there we go. Right. So now I'm going to get -3. Plus E minus 5. Oh, sorry. Right. I feel like that should give me the exact same answer that we got. Okay. Yes, everybody who's done the question, did we end up at this spot? Yes, thumbs up. Amazing. Okay, cool. All right, and then just the only thing left is to calculate for the area. Area is equal to half multiplied by 11.3 times 11.3. I don't know how we're getting a non-decimal answer. Oh, you got 8√2. Okay, that's fine, Abu. That's also perfect. That's a perfect answer. And we need to remember, because it's an area, remember to do that. Otherwise, you lose a mark. If you don't write units squared at the end, we deduct a mark. All right, so 2 marks there, 1 mark for substituting, 1 mark for the answer, and 1 mark for adding in units squared. You will lose a mark if you don't put units squared in. Okay, all right. Okay, so these weren't that difficult. I think these questions were quite nice. Yes, analytical geometry does kind of roll off a little bit, and it makes it a little bit easier. Shall we step it up a little bit of a notch? Yes, let's do some Euclidean geometry. Nobody's favorite subject. But let's try some Euclidean. Okay, so, oh, sorry guys. Sorry, before we even get started. Okay, all right. Okay, so let's slowly go through this, because we know that Euclidean geometry is mainly about proofs. And I can already see this. Nobody likes proofs. Okay, but before we even start with this, let's read through the information a little bit so that we know that we have certain things that we can actually use. Okay, we are told, we are given a parallelogram. We are given a parallelogram. What does that tell me? What does that actually mean for what we're about to do? Okay, good. We're going to use congruence. But what is them telling us that PQRS is a parallelogram? What does that do for us? How does that help us? What can we already... Yes, Katero.
It helps us highlight the properties of a parallelogram.
Absolutely, my darling. Just beautiful work. Because they told us it's a parallelogram, we can already use the properties of a parallelogram, which is very helpful. Okay, good. And then they tell us that we have diagonals, PR and QS, intersecting at M. All right. And those of you who are like, we're going to use the triangles, we're going to use congruence, you're not wrong. You are spot on. Okay. But because they've told us it's the parallelogram, there are certain properties of a parallelogram that we can already assume. Okay. Like what they've given us in the drawing. Look, they tell us that QP is parallel to RS. That's very helpful. They also tell us that PS is parallel to QS. That's also very helpful. Those are things that we're going to need in our proof as we go along. All right. Now the question says here, prove that the diagonals bisect. Give me a thumbs up. Does everybody remember what bisect means? Are we all okay with the word bisect, or do I need to explain what it means? Good. Abu, not just cut in two. Be a little bit more specific. Not just something is cut in two. Okay. The word bisect, exactly. The word bisect, Gift, if I have a line AB. If I have a line AB and line AB is bisected by, let's say, point C. What this tells us is that point C has cut AB directly in half such that AC is equal to CB. So that they cut in half and they're the exact same length away from each other. Does that make sense, Gift? We okay with that idea? Okay. They're cut equally. All right, excellent. That's what the word bisect means. Even if we bisect an angle, it means the angle has been cut directly in half and the one side of the angle is equal to the other side. All right, so if we know that, we need to prove that the diagonals bisect. We cannot use the fact that the diagonals bisect. We can't use that particular property in this particular question. Okay, but we are correct. We are going to have to use two triangles. Okay, now I want us to be very careful. We need to prove that diagonals bisect. Which triangles? Does anybody want to venture for a triangle that we're going to use? Because we know we need an RTP. We are required to prove. Right. Now, Narisha says triangle PQS. Okay. Now, PQS all the way there. If we do that, Narisha, we're going to end up with a bit of a problem. Okay, because if we want to prove that two things bisect each other, we need to prove that QM bisects or is the same length as MS. And we can't do that if QM and MS are in the same triangle. Are we understanding what ma'am is saying? Is everybody okay with that idea? Yes? Okay, so even with the one that Abu has given us, let's go to PQR. If I go to PQR, in order to prove that the diagonals bisect, I will need to prove that PM and MR are equal to each other. So we can't use that big triangle. Now watch what Abu has said. Abu says QPM. That's the one we're looking for. Okay, that's the one we're looking for. We're looking for QMP. QMP. Good, because I now can use one triangle to prove that QM is equal to the other one. SM, it can't be P this time. It would have to be SM. Which triangle would it have to be? From S to M and to, that's the one, Kulani, to R. That's it, Narisha. So that my QM is on its own and my MS is on its own and my PM is on its own and my MR is on its own. Thumbs up. Does everybody understand why ma'am has chosen these particular triangles? If I go to the big triangles, I'm not going to be able to look at each of the parts that have been cut in half. If I want to look at each of the parts that have been cut in half, I need to consider each of them separately. All right, so what do we need to prove here? We need to prove that triangle, and remember, we always need to map them out properly. So I'm going to start Q past the short side and down to the middle. So triangle QPM is congruent to triangle. I've started down here, so this side I'm going to start up there. Down the short side is congruent to triangle SRM. That's it. Good. And you're already onto something, Kulani. We haven't even started yet, but you're already there. Okay. Good stuff. All right. So we now know we need to start our proof. We know exactly how we start the proof. Okay. Proof. In triangle QPM and triangle SRM. How many reasons do I need to prove congruence, guys? 3. Good. I need 3. So 1, 2, 3. Khulani has been so nice to have already given us the very first one that we need. Okay, good. She's already told us that M1, so that one, is equal to M3. Angle M1 is equal to angle M3 because of vertically opposite angles. Vert-op angles. All right. And I'm so happy, Narisha, to see you say that PQ is parallel to SR, because that's going to help us quite a lot. Okay. Not in this case, Kanyo. It's not, because we've taken M and we've broken it up into its separate angles. Okay, so we need to use the fact that PQ is parallel to SR to find another one of the reasons. What is another reason that we can use here, or another statement? Q2 is equal to S2. That's the one. Good. We can say Q2 is equal to S2 because of alternate angles. We can draw alternate angles, right? So Q2 is equal to S2 because of alternate angles. And then I need to say PQ is parallel to SR. Okay, I just want to make sure everybody is still with us. Is everybody okay with this idea? Yes, thumbs up. If not, I can always rewind a little bit and then we can start again. All right. Okay, so I want us to be very careful here, grade 10s. Okay, we are proving congruence. At the moment, you guys have given me an angle because M1 and M3 are an angle. You've also given me Q2 and QS and S2, which are also an angle, which means our third reason cannot be an angle. Correct? Otherwise, we've proven similarity. We now need to find a side. We need to find a side. Okay. I'm going to lean heavily on the fact that they've already told us that PQRS is a parallelogram. What are we able to do with that? Okay, we know that PQ is parallel to SR. What else do we know? That's it. That's it, Javiso. That's it, Narisha. That's the one, Theo. Beautiful. Because we know that it's a parallelogram, we automatically know that PQ, the side PQ, must be equal to the side SR. Agreed? This side and this side must be equal to each other if it's a parallelogram. And our reason here is because the opposite sides of a palm are equal. All right, beautiful. And now we've got a side. And there's our three reasons. Now we can say, therefore, triangle QPM is congruent to triangle S. Find our reason. Let's go find our reason. What is our reason going to be? Okay, I have an angle, and I have a side. On the other side, I have an angle, and I have a side. So our reason for congruence is going to be AAS or S or SAA. I don't think the order really matters of those two, but you can't say ASA. It has to be either AAS or SAA, one of those two. I'm going to go with yours, Theo. I like AAS. We'll stop there. South African Airlines. Yes, that's the one. All right. I just want to make sure everybody's okay with the steps that we've taken here. Yes? Thumbs up? Are we all okay here? Okay. It does take a little bit of thinking outside. Like you need to really think, what am I trying to prove? What is the best way for me to do it? You know, then we can kind of work our way there. All right. Okay. Next thing then we can do, because remember, we're still proving that the diagonals bisect. The proof itself isn't the thing that we want. We're proving that the diagonals bisect. So the next thing we're going to do is we're going to map out our triangle. We already know that QP, side QP, is equal to side SR. We know that for a fact. We've just used it in our proof. It's proved above. We also know that then that side PM, which side must PM be equal to? PM must equal RM. Good. PM must equal RM. Remember, the first two with the first two, the last two with the last two. And then we're going to skip all the way to the end. We now also know that QM, first and last, must equal SM. And we're already seeing it, yes, that we've proven that QM is equal to MS or SM, and we've proven that PM is equal to RM. And that's how we're going to prove that the diagonals bisect. Right, so let's write it out. We're going to then say PM is equal to RM, right? And our reason is because of our congruent triangles. It's a bit annoying, but you actually have to write triangle QPM congruent to triangle SRM. It's very annoying, but we have to do it. Okay, then we can say QM is equal to SM. And again, for the exact same reason, I'm just not going to write it out again. Right, and if these two things are equal to each other, then we can say, therefore, QS. QS or M bisects QS and CR. And there's your 4 marks. Okay. All right. Do we want to try another one, another proof, or are we okay? Thumbs up for another proof, thumbs down. Are we okay with proofs for now? Okay, I'm getting 2 thumbs up. I'm getting quite a few yeses. Okay, let's do this. Let's quickly move on to something else. And if we get to the end and we still want to try a proof, then I'll give you guys another proof to go through. Okay. All right. Here is your next question. Okay, what are we looking at here? What do we see? Good. We see the midpoint formula. Lovely. Okay, we see midpoint. All right. Okay, good. So are we going to be able to do the midpoint, not midpoint formula, sorry, midpoint theorem? Okay, I just wanna see if everybody's okay with how to use the midpoint theorem. Shall we go through it one more time? Okay, let's go through it really quickly. All right, I'm going to remind you guys, okay, that if I have a triangle like this, okay, if I have triangle ABC, okay, and if I draw a point, if D is a point on AB and E is a point on AC, that's D and that's E, and each of them are the midpoints of the other. So if D is the midpoint of AB and E is the midpoint of AC, if I join DE, okay, there are a couple of things that actually happen here. First, we know that AD is equal to DB and AE is equal to EC because they're midpoints, right? But we also then know that DE will then have to be parallel to BC. Okay, that's the midpoint formula theorem, mid-PT theorem. Another thing that we know is that the length of DE will equal half the length of BC. Again, this is midpoint. Okay, midpoint theorem. Okay, so if D is the midpoint of AB and E is the midpoint of AC, then we can conclude that DE is parallel to BC, and we can conclude that if DE is X, then BC should be 2X because DE will be half the length of BC. That's the midpoint theorem. Now, if they give you the fact that BC, if they say this, if they say to you that, let me say DE rather, if they give you this drawing and they tell you that DE is equal to half the length of BC and DE is parallel to BC, then you can then say, therefore, AD is equal to DB and AE is equal to EC. Now, this is not the midpoint theorem. This is the converse, the opposite of the midpoint theorem, the converse mid-PT theorem. All right, everybody okay here? Yes, thumbs up. Are we okay? Write this down. Take a screenshot if you need to. It's quite important that we can tell the distinction. Okay, good. The converse. I'm pretty sure the word converse came before the converse shoe, but we'll leave it there for now. All right. Okay. All right. Let's have a look at the question that we've been given over here. All right. 9.1 says, oh, let's read the information. Oh, guys, I almost forgot to read the information. Let's read the information. Okay. It says here, triangle ABC is a right-angled triangle. It's right-angled at B. F and G are the midpoints of AC and BC respectively. So they've told us that F and G are midpoints. So that's quite helpful because we already know what it is that we can use in order to prove a couple of things. Okay. Then we know H is the midpoint of AG. So H is also a midpoint of a line AG. E lies on AB such that FHE is a straight line. Okay. So we know that the point E still makes this a straight line. So this is connected as a straight line. Okay, and that is actually very important information as we go. All right, this question already out the gate says, prove that E is the midpoint of AB. Now, we have to prove that something is a midpoint. Is that going to be the midpoint theorem or the converse midpoint? What are we thinking? It is the midpoint, but we need to be a little bit specific. Or actually, you know what? I think it's fine. Let's just go with midpoint. Okay, midpoint for now. All right, we'll just say midpoint theorem. I think that's enough. They'll allow that. All right, so we want to prove that E is the midpoint of that line. Okay, now if we want to prove that something is a midpoint, what do we need to prove? Just give me 1 second, guys. AE is equal to EB. Okay, good. All right, let's try and look at it this way. All right, let's try and consolidate the information that we've been given. Excuse me. Okay, what information have they given to us that we can use here? CF is equal to F. Okay. CF is equal to FA. That's actually very helpful. Yes. Okay. So we need to connect some sort of triangle to the whole thing, right? And the triangle must have midpoint somewhere on it. I hear somebody's unmuted. Would they like to talk? Sorry, guys, I just need to take numbers. Just give me a second. Let me see. Okay, 14. Okay, good. Let's see which triangle we can actually work in. Oh, sorry, guys. Can I just quickly answer this? Okay. All right. So remember what we said, guys. Let's have a look at the midpoint theorem. My apologies for being quiet for so long. I just needed to take care of that very quickly. All right. Remember what the midpoint theorem actually tells us. Okay. It says that in order for us to see that anything is a midpoint of something else, we need to have it in an actual triangle. It needs to be in a triangle. There needs to be certain things that are already equal to each other in order for us to prove that. Okay. So, okay, so the first thing we need to do in order to prove that E is a midpoint of the side AB is we need to choose a particular triangle that's going to help us with that. Okay, so Narisha says, in triangle ABC. Are we all in agreement, the big triangle? Yes, are we all good there? Does that help us? Okay. ABC and ABG, I think. Okay. I think we've got the wrong triangle. Okay. I'll tell you why. In order for this theorem to work, I'm going to need both sides of my triangle to do the right things. So which triangle actually has the things that I need? It's not going to be ABC because BE and EA have not been proven. Okay. I'm hearing somebody's unmuted. Okay, ABG. Okay, Lutendo says ABG. I think we're going to run into the same problem again, Lutendo, because if I say ABG, that's still not going to help me. I don't know what BE or EA is. Okay, think about it carefully, guys. It doesn't have to be a right-angled triangle. That's the one. That's the one, Narisha. That's a Theo. AGC, lovely. Okay. I just want to double check. Thumbs up. Does everybody understand why it's best to choose triangle AGC? No? Okay, Lutenda's a bit confused. Good, Narisha, good. It has more information. Okay, if we choose the triangle with E in it, if we use triangle ABG maybe, we only have one set of equal sides, right? If we use the big triangle ABC, we only have one set of equal sides. These sides, we don't know if they're equal. But if we choose triangle AGC, look at it, triangle AGC, that's it, triangle AGC, then we've got two pairs of equal sides. I have AH is equal to HG, and I have that AF is equal to FC. Does that make sense, Lieutenant? Are we okay with that? Is everyone okay with why we've picked that particular triangle? Good, because then we've got that statement. We have that statement for us to use. Okay, we can start there. All right, so there are a couple of things that we can already talk about here. Okay, first thing we can say is we're going to point out the obvious, but we're going to use it to get to the answer that we want. I'm going to erase some of this. Sorry, guys. Okay, so 9.1. Let's name the triangle we're going to be working in. In triangle, that's a shocking in. In triangle AGC, we know that AH is equal to HG. That's given information. And we also know that AF is equal to FC. That's also given. What part of the midpoint theorem does that prove for us? What does that then tell us? If those two are equal to each other, it's written right here, guys. It's right over here. What does that then tell us? Anybody got an idea? If AD is equal to DB and AE is equal to EB, then what do we know? No, we can't just say midpoint theorem. What does the midpoint theorem tell us? What does the midpoint theorem tell us about that line and that line? What do we know about those two lines? Not equal, they are parallel. Good. That they are parallel. Okay, it's that part of our theorem. That part there. Okay, so if we know that those two sides are equal to each other, we can then say that HF is parallel to GC. Do you understand where I'm coming from? Kabisa, are you okay with this idea? Okay, good. They are parallel to each other. But if we know, oh, sorry, I forgot the reason. We must add in here mid-PT theorem. Okay, we must add that in here. Okay, if we know, excuse me, if we know that those two are equal and we know that HF is parallel to GC, let's just go back quickly to the other information that they've given us. They've told us that E lies on AB such that FHE is a straight line, right? Good. EF is a straight line, which then means that this whole thing must therefore be parallel to that whole thing. Are we okay with that idea? It's not the converse, my darling. It's still the same. It's still the midpoint theorem. In fact, it's not even the midpoint theorem. It's given. It's given information. So therefore, we know that the whole of EF must be parallel to the whole of BC. Okay. All right. I just want to make sure, does everybody understand where ma'am is coming from with this question? Yes? I hope we're okay. I hope I haven't lost anyone. Okay, the reason we do that is because of the straight lines. Okay. All right, now that we've got that information, that's quite helpful because now we can go from the smaller triangle into the bigger triangle. We can now work in the bigger triangle. All right. Then we can say, oh, excuse me. Okay. Then if we know that EF is parallel to BC, we can therefore say that E is the midpoint, okay, because they're parallel to each other. And that, Narisha, now you would be correct in saying that this is the converse of it, all right? So this is converse mid-PT theorem, and we've proved it above. Okay, you can even write here, proved above, because we've just done that. Okay, there it is. Okay, this one is a bit of a complicated one, I agree. Okay, should I look for something a little bit more palatable? Yes, okay, I'm going out with, I'm really sorry. Why not invite us here? Just leave us here. How? Invite us. Where are you going? Are we going to Spur? Are we going to dinner? Invite us also. We also want to eat. Okay. All right. Okay, I actually do want us to do question 9.2. Oh, okay. You're boring. It's fine. I've been to the shops before. It's fine. Okay, let's do 9.2. Have a good evening. No, have a good evening, Sia. Enjoy going to the shops with your parents. In the business exam. That's cute, though. That's very cute. All right, let's have a look at 9.2 quickly. So it says here, and 9.2 really doesn't have anything to do with the midpoint theorem. So I'm going to erase it. It doesn't have anything at all to do with the midpoint theorem, but I want us to have a look at the question either way. Okay, so it says here, if EH is 3.5 centimeters, okay, now they're speaking about this tiny piece from there to there. EH, this is 3.5 centimeters. By the way, what is the size of the angle over here? I'd like to remind you that in 9.1, we just proved that that is parallel to that. So what is the angle that we're looking at over here? It's a 90-degree angle. Good. All right. So that's 90 degrees. We know that EH is 3.5 centimeters long. It says here, the area of triangle AEH is 9.5 centimeters squared. So let's go and map out AEH. That is AEH, that triangle there. They say determine the length of AB. Determine the length of that, which is easy enough. We don't need that second part just yet, right? We're calculating for the area of a triangle. We know the formula for the area of a triangle. Yes, thumbs up. We've just gone through it. We know exactly what the area of a triangle is. The area of a triangle is half the base multiplied by the perpendicular height. Now, I want us to note here what they've given us. They have given us the length, or they've given us the length of our base. Do we see that that's the base? They've given us the base. They've also given us the area. They've told us what the area is. So what do they actually want us to calculate for? Good. We're actually calculating for the perpendicular height. We're calculating for that part there, for the perpendicular height. Are we all able to do that? Thumbs up. Can I give you guys some time to try that? Yes? Okay, I'll give you guys 2 minutes. It shouldn't take us that long. Okay, I just want you guys to find me the length of EA, which is the perpendicular height. And we can do that by subbing everything into the formula. All right. And just correct to 1 decimal place, guys. Don't stress about too many decimal places. Oh, Narisha, don't rub it in. We're all quite cold. Yeah, Theo, it's not a good. I don't think this summer is summering in the way that we thought that the summer would summer. Yeah, I agree, Javiso, I agree. It's winter. Yeah. All right, guys, let's have a look at the answer. Okay, so I'm going to replace the area with 9.5. Okay, 9,5 is equal to half times 3,5 times the height. Now, I know that if I want the height on its own, I'm going to have to divide both sides by half times 3.5. Let me just make sure I've got the correct answer. So divide the side by half times 3.5. Okay, those will cancel out. Therefore, the length of EA should equal 5.4 centimeters. Did everybody get 5.4 centimeters? Yes, did we manage? Beautiful, Wikanyo. Amazing stuff. Good. 5.4 centimeters. Now, let's make sure we're understanding the question fully, because the question doesn't want the length of EA. The question wants the length of AB. It wants the length of AB. So not from here to there, but all the way from here all the way to there. So that whole distance there. Okay. But we know some things. Before, we had just figured out that E is the midpoint, right? Okay, yes, good. So we know that E is the midpoint. And if we have the length of EA, that automatically means we also have the length of which other part? Correct, Narisha, you're spot on. Right. If we know that EA is 5.4 and E is the midpoint, that means EB must also be 5.4. Both of them must be 5.4. So I know that EA is equal to 5.4. Therefore, EB is equal to 5.4. And that will then give us the distance AB. AB is therefore equal to 10.8 centimeters. All right, nice and simple question. Not that difficult at all. It's not like number one, where you really have to know what you're doing. All right, in this one, we can kind of get the idea.